Hi, in this video, we will learn how to solve the improper integral. Proper and improper integral are under the definite integral, where you have the limit here. So for the proper integral, our limit is finite. For example, you have finite number 1 and 2 for the lower and upper limit respectively. However, if you have infinite number at the upper or the lower limit, then this type of integration is called the improper integral. For the proper integral, the function inside this integration must be well defined and bounded. For example, in this case, the function 1 over x squared will become infinity and undefined when you substitute x equal to 0 inside. Therefore, to ensure that this function is defined and bounded, the x cannot be equal to 0. However, in this case, if the function is unbounded and the x can be equal to 0, so in this case, if you substitute x equal to 0 inside, you get infinity function, which is undefined. Therefore, this is one of the improper integral as well. So how can we find the solution for this type of improper integral? So far, you know that we have two types of improper integral. First type is due to the infinite interval, where you have the infinity or negative infinity at the lower and upper limit. For the second type, you have the discontinuous integral, where the function here is undefined at certain x. For the first type, you might have the infinity limit at the upper limit, or at the lower limit, or at both. So to check these three integration, whether they can be solved or not, then you can follow these three approaches. So you need to solve the problem by using the limit approach here, where you can see you replace the infinity by a variable t here, and then you take the limit for this variable to be approaching infinity or negative infinity. If the solution here gives you some finite number, then we say is converged and the solution exists. If you get infinity solution, then it means that the solution is not exist and it is diverged. To check if you have solution for the third integration here, you need to perform this operation. So you have the negative infinity at the lower limit here. A can be any number. So if you solve this and you obtain some finite number, then we say is partly converged. Then you have to check for the second integration here. So you integrate from a to infinity. So if this is finite number also, summation of these two integration results will give you finite number as well. Therefore, we can say that this integration has finite solution and the solution is converged. However, if you obtain one of the integration result here is not finite or undefined, then the summation of this will be undefined as well. And we can say that this integration result is not exist and it is diverged. We can use the same approach to check the improper integral due to the discontinuous integral here, whether the solution is exist or undefined. For the first case, if the function is undefined at x equal to b, then we can substitute the t to the upper limit. So you have the lower limit a and t and b here, where the t is approaching b from the left hand side. Therefore, we can take this limit. If the fx function here is undefined when the x is equal to the lower limit a, then you can substitute the variable t to be the lower limit here and take the limit like this, because you have the a, t and b here, where your t is approaching to a from the right hand side. After you compute the limit and integration here, and if you obtain finite number, then we say the solution exists and it is converged. If you obtain some infinity number like this, then the solution is undefined and is diverged. For the third case, the fx function here is undefined when the x is equal to c, and the c is between a and b. Therefore, you need to form this equation, where you integrate from a, which is the lower limit, to the c, and from c to the upper limit b. So if you take the integration for these two and you find that both of them are finite number, then you can take the summation of these two finite number and obtain the resultant. So the resultant will be equal to finite number also in this case. Therefore, we can say that this integration is exists and it is converged. If one of the solutions here or both of them are infinity, then the final solution here will be infinity as well, which is diverged. Let's see the example to solve the improper integral for type 1 here. So you have infinity at the upper limit, therefore you substitute the variable t at the upper limit and take the limit t approaching the infinity. So we can solve the integration here to obtain this, and you can substitute the upper limit and lower limit inside and take the limit t approaching infinity. So the final result gives you infinity, which means the solution does not exist and it is diverged. So for the second case here, you have negative infinity at the lower limit. Therefore, you substitute it by the variable t and take the limit t approaching the negative infinity. So take the integration here, you obtain this, and substitute the lower and upper limit inside and take the subtraction. So after you take the limit for this, and you should obtain infinity for this case, and we can say that this case is diverged also. For the third case, you have negative infinity and infinity at the lower and upper limit. So in this case, you need to form the equation here, where you take the integration from negative infinity to any number. So in this case, you substitute the number to be 1, and take the integration from the same number a here, which is 1, to infinity. So we solve it separately. For the first part is this, so you obtain infinity from it. For the second part here is this, and you obtain infinity also. So if you have the summation between two infinity result, then the solution here is infinity as well. Therefore, we can say it is diverged. Let's solve the second type of improper integral. So in this case, you can see that the function here is undefined when the x is equal to 0, and the lower limit happens to be 0. So in this case, you need to replace the variable t to the lower limit, and you have 0, 2, and you replace the t approaching to 0 from the right hand side. Therefore, you can take this limit. So we solve the integration here, and you should obtain this, and you substitute the upper and lower limit inside and take the limit. So the solution is infinity, which means the solution doesn't yet exist and the solution is diverged. For the second case, this function is undefined at x equal to 0, and you see the upper limit has the 0. Therefore, you need to substitute the variable t to it. So you have negative 2 to 0, and the t is approaching to 0 from the left side. Therefore, you have this limit. So you take the integration and you should obtain this. Substitute the limit here inside and take the limit, and you should obtain the result equal to infinity. This means that the solution doesn't exist and it is diverged. For the last case, the function is undefined at x equal to 0, and you don't have 0 number at the lower and upper limit. So in this case, you need to form the equation here, where you take the integration from negative 2 to 0, which causes the function to be undefined, and take the 0 to 2. For the range of the x, you have negative 2 to 2, and you know that 0 here is undefined. Therefore, for the first integration here, you take the limit from negative 2 to 0 from the left hand side. So you can see 0 power of negative here, right? So if you continue for the second integration here, you continue from 0 from the right hand side to 2. Therefore you have 0 positive to 2. So you have solved this integration before and you obtain infinity result. Therefore, the summation of infinity result gives you infinity here also. So in this case, you obtain diverse solution. We have more example here where you solve the improper integral to obtain some convergent solution. The approach to solve the problem is still remain the same. However, in this case, if you substitute the limit inside, you obtain some finite number. Substitute the t equal to x inside, you obtain this. Substitute the x equal to 0 inside, you obtain exponential 0, which gives you 1. 1 multiplied with the coefficient here, and you should obtain this answer. And take the limit here, you have the exponential negative infinity square, which gives you 0. Therefore, you only have the 1 over 2 as the result. Similarly, substitute the limit here inside, then you should obtain this answer. And take the limit t approximate to negative infinity, so this term will become 0, and you only have negative 1 over 2 remain. Therefore, for these two cases, we can say that the improper integral have converged solution for these two cases. If you want to find this integral, then you need to take the summation of the integration from negative infinity to any number of constant. Let's say the c is equal to 0 in this case. And take the summation of integration from the c to infinity. So since you have solved this before, we can substitute it inside, and from here the summation is equal to 0. Since the final answer is finite number, therefore we can say that this improper integral is converged. To solve this improper integral, so the function here is undefined when the x is equal to 0. So you have the lower limit equal to 0 here and upper limit equal to 0 here. Therefore, you need to replace them by using the variable t and take the corresponding limit. So you can solve the integral to obtain this. Once you substitute the limit inside, then you should obtain this result. And limit here, after you substitute, you should obtain this. When the t is approaching 0 from the right side, so you take the limit, this term will be 0, therefore you obtain the final answer equal to this. When the t is approaching 0 from the left side, so this term will become 0, so you only obtain the negative 2 square root 2. So these are the final answer, therefore we can say that these two improper integral has converged solution. Lastly, you want to integrate the improper integral here where the function here is undefined when x equal to 0. So in this case, you need to integrate from negative 2 to the 0 negative and from 0 positive to 2. We have solved this before, so you can substitute the final answer here and take the summation, then you should obtain 0. Since the final answer is in finite number, therefore we can say that this improper integral has converged solution. In this example, we have an improper integral where the upper limit is undefined. So you need to solve it using some limit. However, in this case, you can see that the function here, gx, is difficult to integrate. So if you draw the gx function, then you will obtain this red line. In this graph, you can see there is a one blue line, which is the fx function. And you can see the fx function is greater than the gx function here. So if you solve the improper integral for the fx function, so this can be solved easier because the fx function here is more simple. So after you integrate this, you should obtain negative 1 over x. And you take the corresponding limit. So after that, you substitute this inside, you should obtain negative 1 over t plus 1 over 2. Take the limit of t approaching infinity, 1 over infinity give you 0. Therefore, you have the 1 over 2 as the solution. So we know that this improper integral is converged. And we can use this information to find the improper integral here, whether it is converged or diverged, by using the comparison test. So this is the definition. You can see that if the function fx, where the fx must be greater than gx in this case, if the fx here is converged, like the case here, your fx is converged, then the gx at below will be converged as well. Therefore, from here we can say that this integration will be converged without computation of this complicated integration. So another comparison test is if the gx function here is diverged. So if this is diverged, then your fx function will be diverged also. So we can use this comparison test to evaluate our improper integral with more easier approach. Improper integral can be used to find the escape velocity. For example, in this case, you want to escape or throw an object to be escaped from the Earth. So what would be the velocity that is great enough to escape from it? Let the r0 here to be the distance from the center of the Earth to the object, which is given by this number. We know that the mass of the Earth is given by this number, and the gravitational constant is given by this. Assume that the mass that is required to escape from the Earth is equal to 70 kg. So when you escape from the Earth, when you measure the distance from the center of the Earth, it should be great enough, such a way that they can escape. So in this case, the radius of the Earth, we are not sure how much is considered big enough, therefore we put infinity. The gravitational force between mass 1 and mass 2 are given by this formula. And to compute the work done or the total energy required for the mass to escape from the Earth, which is the r0, to r infinity, you need to multiply the force with the distance to obtain the work done and integrate it from r0 to infinity. You should understand the infinity here means that the radius is very large and is unknown in advance, where the upper limit is infinity. So for this usual form of improper integral, we can convert into exact definition by replacing the infinity by t and take the limit of t approaching infinity. Since the g m1, m2 here is constant, therefore we can extract it out, and then you continue to integrate 1 over r squared, then you should obtain negative 1 over r. And substitute the limit inside, you should obtain negative 1 over t, minus minus, you obtain positive, and 1 over r0. So you take the limit when t approach infinity, 1 over infinity give you 0. And therefore you obtain 1 over r0. So after you substitute all the data inside, then you obtain the total energy required to escape from the Earth. So we know that the kinetic energy is given by 1 over 2 mv squared and is equal to this number. So by having the mass equal to 70 kg, from this equation you can solve for the v. And for a 70 kg rocket here, the escape velocity needed to escape from the Earth is computed, and you obtain the velocity is equal to 11.2 km per second. For your extra information, in more advanced mathematics class, you will learn how to apply the improper integral to find the Laplace transform or the Fourier transform. So these two transforms are useful to convert the time domain signal into frequency domain signal, where the omega is the frequency, or the Laplace domain signal. So you have The t variable you can convert to omega variable by using the Fourier transform, and you can convert from t variable to the x variable by using the Laplace transform. You will learn this more later on.